Good morning, everyone. In today's lecture, we are going to see about method overloading and overriding, abstract class, packages, and interfaces. Uh, Myself, S. Chakravarti, Assistant Professor, Department of Information Technology, Ramco Institute of Technology, Rajapalayam. So, in Java object-oriented programming, so the important topic is method overloading, method overriding, abstract class, packages, and interfaces. Me- What is method overloading? So, method overloading means a class can have more than one method, but with same name, but they differ in their parameter list. This feature is called method overloading. So, a method with the same name, but with different parameters is said to be method overloading. There are two ways to overload the method by changing the number of arguments, by changing the data type. Let's see with an example program. Here, the class name is adder, and we have a static int add of int a comma b. It's a static method which contains the method definition return a plus b, and another method with the same name static int add of, but with different number of parameters. That is int a, int b, int c. So here the add method is same and is available in the class adder, but they differ in their number of arguments. Here the argument is 2, whereas in the add method, the second add method, the number of argument is 3. Right? So, and the public class, class name overloading demo, main method, public static void main of string arguments array, and system.out.println, adder.add of 10, comma 5. Then system.out.println, adder.add of 10, comma 5, comma 6. So we are calling the method add of with the two arguments and with three arguments. So this is said to be a compile time polymorphism, because the binding the method call with the method body is determined at the compile time. So it's said to be compile time polymorphism. So the very good example for compile time polymorphism is method overloading. So the definition is method overloading means a class may have more than one method with the same name but with different parameter types or in differ in their number of arguments. So method overloading. So output, so 15, 21, right? So 10 plus 5, 5, and 10, 15, 10 plus 5 plus 6, 21. Then the next one is we can overload the methods by changing the data type of the arguments. In the first case, we, we write the program by changing the number of arguments. In the second case, method overloading by changing the data type of arguments, we are changing the data type, but having the same number of arguments. Let's see. The class name is adder and static int add of int a comma b. So return a plus b. Static float add of float a comma float b comma float c. Right. So here the number of argument is 3 and number of argument is 2. Also, they differ in their data types. There is here integer, here float. So, in main method, we are calling the method add of. So, since the method is static method, we are calling with the class name. That is class name dot add of. Suppose if it is a non-static method, just int add of, we will create the object for the class adder. Then using that object, we can invoke the method add of. Right? For example, if I am not using the static keyword here, so in that case, I have to invoke the add of method after creating the object of the adder class. So we have to add the code, that is adder object equal to new adder of. Then using the object, we can call the method add of. So in this case, I am using the static method. So no need to create the object for the adder class. Instead of by using the class name itself, we can invoke the method add. So the benefits of method overloading are which increases the readability of the program. we can call the same method with the different types of parameters and different types of data and reduce the execution time because the binding is done in compilation itself and use the code again, which saves the memory. So these are the some of the advantages of method overloading feature. And the next concept is method overriding. So method overriding refers to the ability of a subclass to provide a specific implementation of a method that is already defined in its superclass. So in order to perform the method overriding, we need two class and there must be an inheritance relationship, ECA relationships. So it allows the subclass to modify the behavior of an inherited method from its superclass. Here the rules are method must have same name as in the parent class and method must have same parameter as in the parent class. There must be a relationship, that is inheritance. We need two classes to perform the method overloading. Whereas in method overloading, we can perform method overloading within the same class, right? We need only one class. Within the class, we can have n number of methods, but with the same name and differ in the number of parameters. So there's a difference between the method overloading and method overriding. Let's see with the example program here. Here the class I'm using is class bank. So int get rate of interest returns 0. Then class SBI extends bank, class Bank of India extends bank, uh, and I am overriding the method present in the parent class bank in the subclass SBI. So class SBI extends bank. So here SBI is a subclass and bank is a parent class. Just I am overriding the method get rate of interest in the subclass and redefining the definition, that is return 3. In the base class, the method definition is return 0. Now I am redefining or I am providing the specific implementation for the SBI class, that is return 3. And bank of interest, also I am redefining the get rate of interest as return 4. In the main class, that is I am creating the object for the SBI and Bank of India and invoking the method get rate of interest with the object SBI, and again the same method get rate of interest. Now the get rate of interest method is invoked with the object of BOI. So now the corresponding method will be invoked in the SBI and BOI dot get rate of interest will invoke the get rate of interest method in the BOI class. So this is the output. So 3, 4. Here the determination of method call, that is connecting the method call to the method body, is determined at the runtime, is said to be a runtime polymorphism or dynamic binding, right? So the best example for there is a runtime polymorphism is method overriding, whereas the best example for compile time polymorphism is method overloading, right? So some of the difference between the method overloading and method overriding. So it's performed within the class, and method overriding is occurs between two classes that have a relationship. In method overloading, parameters must be different. And in method overriding, parameters must be same. Return type can be same or different in method overloading. Return type must be same in method overriding. And method overloading is used to increase the readability of the program, whereas the method overriding is used to provide the specific implementation of the method that is already provided by its superclass. Method overloading is the example of compile time polymorphism, whereas the method overriding is the example of runtime polymorphism. And again, one of the difference is the program, right? We are providing the add of method with and they differ in their number of arguments. Here the argument is 2 and here the argument is 3. In method overriding, we need two class. So I am using the class animal and class dog. Right? So the dynamic method dispatch. So dynamic method dispatch is the process by which a call to an overridden method is resolved at runtime. The process is said to be dynamic method dispatch. So the concept of method overriding is the way to attain runtime polymorphism in Java. During the code execution, the Java virtual machine decides which implementation of the same method should be called. So there is dynamic binding. So dynamic method dispatch is another name for runtime polymorphism. Okay. So method overloading is an example for compile time polymorphism. Method overriding is an example for uh, runtime polymorphism. The next topic is abstract class. So abstract class is a class that is declared with the keyword abstract, and it have abstract method and non-abstract method. So abstract class by which we can achieve the one of the object-oriented programming concept, that is abstraction. So abstraction, we know abstraction is the showing the essential feature and hiding the implementation detail. That is the one of the OOPS concepts. How can we achieve the abstraction feature in Java? Means using the concept abstract class. So, so the abstract class may have abstract method and non-abstract method. So by the way, we can achieve 0 to 100% abstraction. 0 to 100% abstraction in the sense the class may not have abstract methods or it may have abstract method, right? Suppose for example, in a class I have 5 methods, out of which are 10 methods, out of which 5 methods are abstract method and 5 methods are non-abstract method. Means here we achieve the abstraction as 50 percentage because 5 methods out of 10 methods, 5 methods abstract method, 5 methods non-abstract method. So here we achieve the abstraction as 50 percentage, right? So the next concept is the abstract method. So it's a method that is declared without any implementation, right? So that is the abstract method. The abstract class needs to be extended and it must be implemented. So an abstract class for which the object cannot be created. That is, the instantiation is not possible for a abstract class. So this is a simple syntax, that is abstract class, class name, then abstract method and non-abstract method. So the method which declared as with the keyword abstract and does not have implementation is known as abstract method. The syntax for abstract method is abstract return type method name with the parameter list. The next topic is the final keyword. In Java, the final keyword is used to restrict the user. Right? The Java final keyword can be used in many contexts. It can be applied with variable. It can be declared with method. It can be declared with the class. When we declare the variable with final, is said to be a final variable. The value cannot be changed once it has been initialized. That is, it's simply like constants. So this is useful for declaring constants or other values that should not be modified. So the final method, when the method is declared as final, it cannot be overridden by a subclass. And final class, when a class is declared as final, it cannot be extended by a subclass. Let's see a program, how we can declare a variable with final. Right? Here, the class name is bike, and I am declaring the variable speed limit of type integer, and it comes and it's declared with the final keyword. So in runoff method, I'm trying to update the value 400 for the speed limit. So since the variable speed limit is final, this value 400 cannot be assigned to the speed limit. So, which means the speed limit is a final variable, value cannot be changed once it is assigned. Look here, in the main method, I am creating the object and b.run, so the value cannot be changed. So there is the example of final variable. Then using final variable, we can provide inheritance. Inheritance means when we declared a class with the final keyword, that class cannot be extended with the subclass. Here class B extends A is a illegal access because A is the final class. So as per the definition, when a class is declared with the final keyword, that class cannot be used as a parent class for another class. So class B extends A is illegal. The definition also says that when a class is declared as final, it cannot be subclassed. So no other class can extend it. And for example, when creating an immutable class like predefined string class, so this is the best example for uh, final class. So declaring a class as final implicitly declares all of its method as also final. So the method contained in the final class also is a final method. And using final keyword, we can prevent the overriding, right? So there is method cannot be overridden. So when a method is declared as final, then it cannot be overridden by subclass. For example, the object class does this, a number of methods are final. So here I am giving one more example, that is class A, final void message. Here the message method is final. So it cannot be overridden in the subclass, right? Here in the B class, I'm trying to override the method message, but it throw error. Right? The next topic is packages and interfaces. So what is package? So a package is a collection of similar types of subpackages, interfaces, and classes. So in Java, there are two types of package, built-in package and user-defined packages. We have n number of built-in packages, and we can create our own package, that is user-defined package. The syntax for creating our own package is, the syntax is package, package, package name. Is the syntax to declare a package and built-in package. So this package consists of a large number of classes which are part of Java API. Commonly used packages are language package, IO package, and util package. The language package is a default package which contains language support classes which define primitive types, math operations, and this is automatically imported. There is the default package is language package, IO package which contains classes for supporting input and output operations, and util package contains utility classes like scanners, date, and time. And some of the examples of built-in packages: applet package, abstract windowing toolkit package, network package. For designing graphical applications, we are using the AWT package and applet packages and net package and networking program using java.net packages. So classes for creating applets, AWT contains classes for implementing the commands for graphical user interface controls like buttons, menus, checkbox, etc. And network operations, net package. Then user-defined package. Suppose we want to create our own user-defined package, we can use our package. So for that, we need to declare the statement package name. So subpackage. Packages that are defined inside another package is called subpackage. These are not imported by default. They have to import it explicitly. For example, import java.util.star. Here util is a subpackage and Java is a main package. Then packages and member access. So from this table, we can infer some knowledge. That is the class private means that is here no. That means the private access modifier cannot be applied to a class. So the no class will be private. And also the class is, we can apply the default access specifier for a class. Protected? No. A class cannot be protected and a class can be public. Right? So here S for default and S for public only. So no class is private and no class will be protected, which means private class A, private class protected class A. So that is illegal. The declaration is illegal. And variable. For example, I am declaring a variable int A. We can declare the variable private int A. That is yes. Or int A. If I am not using the access modifiers, that is which means it is default. And another variable we can declare as protected int A or protected public int A. So these are some of the examples for variables. So and the next one is method. In method also we can declare a method with the access specifier private, default, protected, and public. Constructor also we can declare the constructor with the specific access specifier private, default, protected, and public. In the case of interface, we can declare or define an interface with the keyword default and public or not by the access modifiers private and protected. So this should be keep in mind, that is a class cannot be private, a class cannot be protected, and interface cannot be private, interface cannot be protected. So that's the concept here. And package and member access within class, that is scope. We are defining the scope here. Horizontally we deal with the within class, within package, outside the package, by subclass only, outside package, which means a private class is the members are accessible only within the class or not within the package. And also outside the package is also not permitted. Then default. So default within the class is permissible, within the package is also permissible, outside the package and through inheritance and outside the package is also restricted. In protected, within the class is permissible, within the package permissible, outside the package through inheritance is permissible, outside the package is not permissible. When a class is declared with key and modifier public, within the class we can access the members of the class. Within the package also, we can access the members of the class. Outside the package through inheritance, we can access the members of the class is accessible outside the package when the class is declared with the modifier public. So that is the inference from this table. First, see the private access specifier. The name itself, it is accessible only within the class. So when it is applied to a class, it's accessible only within the class. It cannot be accessed from outside the class. So let's see a scenario. Create two classes A and like another class name is simple. The class A contains private data members and private method. When accessing these private members from outside the class, the error will be thrown at compile time. Let's see with the program. Class A, private int data, private void message. Public class simple. And main method, class A. I am trying to create an object for the class A within the class simple. But the class A is, the class A members are private. So the private data members can be accessible only within the class. It is not permissible to access the members of the private class or the private members from outside the package or that is outside the package is not permissible. So here it throws the compile time error. We can't create the object for the class A since the members present in the class A is or private. So it throws compile time error. And default access specifier is accessible only within the package. It cannot be accessed from outside the package. It provides more accessibility than private, but it is more restrictive than protected and public. If no access modifiers is specified, then it is treated as default modifiers. So let's see the example program. Here I am declaring the package, there is package pack class A. Within the class A, I am defining the method message of. So now the class A belongs to the package pack, and in the right side, class B belongs to the package my pack. And I am importing the package pack in the B class. There is my pack. There is import pack dot star, and I am trying to access the class A present in the package pack from my pack. So as per definition, when a package is in default, when a class is in default specifier, that class can be accessed only within the class and within the package. Here, the class A is declared with the default access specifier. These class members are accessible only by the class or the classes available in the package pack, not from the outside package. So here the class B is present in another package, this my pack. So it is not accessible from the B class. So it throws a compile time error. So protected access specifier. So it's accessible within the package and outside the package, but through inheritance only. So here the class A is now available in the package pack and class B available in the package my pack, and I am importing the pack and extends the A and creating the object. Now it is permissible because the class A is in the class A present in the pack and the message available in the class A is protected. So we can access the class A members through inheritance concepts because the message is protected. So we can access the members from outside the package. So as per definition, the protected access specifier is accessible within the package and outside the package, but through inheritance. We are performing the inheritance. Class B extends A. So it is permissible. So the output is hello. Right? We can create the object for the class B and we can access the method message of. The message of method is not available in the class B, but it is invoking the message of method present in the parent class A. Parent class A. So it is permissive because we are using the protected access specifier. Then public access specifier. Public access specifier is accessible everywhere. It has the wider scope among all other modifiers. So within the package, outside the package, we can access the members of the public class. So we can access the message of method from the class B, right? By importing the corresponding pack. So import pack dot star class B public static void main A object equal to new A of object on message of. Here I am not extending the class A, even though I am accessing the message of method. There is invoking the message of method because the class is in public access modifier. So we can access the members of the public class from outside the package, right? So as per the definition, we can access the members of the public class. So this is an example for public modifier. So some of the advantages of packages is used to categorize the classes and interfaces so that it can be easily maintained and provide access protection, and it removes naming collisions. So importing packages, the import keyword is used to access all members of a package using the following statement, that is import package dot star import package dot class name. Interface. So interface is a blueprint of a class. It has static constants and abstract methods. The interface in Java is a mechanism to achieve abstractions. Again, so object-oriented programming concept is one of the object-oriented programming concepts is abstraction. In Java, abstraction can be achieved by two ways. One is abstract class and another one is interface. In abstract class, we can achieve 0 to 100% abstraction, whereas in interface, we can achieve 100% abstraction because interface contains only abstract method and it doesn't allow non-abstract method. So there can be only abstract method in the Java interface, not method body. It is used to achieve abstraction and also multiple inheritance in Java. So syntax of interface, interface name, declaring the variables in the interface is by default it's a constant field, constant one, and the method by default abstract method. So it's a simple pictorial representation, that is interface name int mean equal to 5 and void printf. After compilation, so the compiler will automatically recognize the variable as public static final and the method as public abstract by default. So even though I am not declaring the variable as public static final and method as abstract, the compiler add the keywords public static final and public static abstract since it is contained in the interface. So the compiler will automatically add the public static final for variable and public abstract for the method. So a simple example for interface. So interface name, int variable. So here the variable is constant and the method is abstract. So class A implements. So implements is the keyword for implementing the interfaces. So printable. Whereas suppose if we want to use the class means we have to use the keyword extends. Right? Class A implements printable, public void print of system.out.println value, we are printing the value. So public static void mean A object equal to new A of then object dot print. So we are creating the object for the class A. Using the object, I am invoking the interface. There is a method, abstract method print of, which is redefined in the class A. So print of. So output will be value min and 5. So this is a simple example for interface. So in interface, we are using the keyword interface name, variable, and one method, abstract method. And I am going to implement the interface using the keyword implements and redefining the printf method and invoking the method printf after creating the object for the class. So some of the advantages of interfaces is used to achieve multiple inheritance and can be used to enforce a contract. There is specification that the classes must implement certain methods if they want to use that interface. So the references, some of the references are Java T points. Okay. So in this lecture, we learned about what is method overloading, what is method overriding, and abstract classes, final variables, final methods, and interfaces. So hope this video will be very useful for the very useful. Thank you.